Okay, sounds good. Thank you. Okay, so we are at 2 o'clock right now. It's a nice Saturday afternoon. Hello, everyone. My name is Jack Lin. I am here on the robotics team at UCSC. I'm part of the mechanical team. I'm the mechanical co-lead along with Naomi. So today we're going to go over a couple of things, but before that, let me go ahead and pass the mic to Naomi to do a quick short introduction.
Hello, everyone. I'm Naomi. I'm also on SolidWorks. I'm the mechanical co-lead with Jack.
And so robotics at UCSC, we do a bunch of stuff. We do everything pretty much. We have a lot of different projects. One of the most focused upon ones is the Make ROV competition. We basically build an underwater robot to do a bunch of tasks, grab stuff, move stuff around, clean up the waterways, replace broken pipes, etc., and do some autonomous driving, 3D mapping, etc. So to support all that, we need to do a lot of CAD work to not only make the 3D model of the robot, but also make 3D models for things we're going to cut and print out and things like that. So today we're going to go over a couple things that might be helpful for you guys, specifically for SolidWorks. This will include a bunch of stuff, as you'll see shortly, in the table of contents. So here is a brief list, or rather the full list, I suppose, of things we're going to go over today and tomorrow. So you see here on the left side, we'll see the table of contents for today, and on the right, stuff for tomorrow. So we'll first go over navigation, how to navigate around in SolidWorks, using the mouse, using keyboard shortcuts, etc. After that, we'll go into sketches and features. These are pretty straightforward, but there's some neat tools you may not be familiar with, and also some good practices to stick to as well. Once we're past that, we'll go into some more weirder tools like global variables and section view in SolidWorks. Following that, there'll be a short break, and then we'll transition into talking about 3D printing, how to make the models you make in SolidWorks or other software into an actual reality you can hold in your hand and put in your robot. And then at the very end, we'll have a Q&A where we can share designs, do a peer review, see if you guys want any tips or tricks on something you guys are working on, or we can also show off some stuff we're working on here at robotics. Okay. Any questions or concerns or things you want to add to the list here? And if anything does pop up, feel free to just speak up and interrupt me or Naomi as we give this little walkthrough. All right, one more thing. The format of this is not going to be stare at the presentation screen for the whole 2 hours. We're going to swap between the presentation for some overview tips and then head over into SolidWorks to show you guys how it's done and how you might, some pitfalls you might fall into. Okay, so, and of course, yeah, do interrupt me, please, if you have questions or something, because I tend to speak fast and not check chat enough, which I should. Okay, okay, so let's go ahead and get started. We were here on part 1, and I suppose I can start off with this first one, navigation. So let me share my whole screen right now. Okay, I think that should work. So when you're using SolidWorks, it's painful to do it on a trackpad. I hope you never have to do it on a trackpad. Trackpad 3D modeling is terrible, and it's very painful because the middle mouse button is really important for navigation. Lets you do rotations around the points along with other things based on other modifier keys you hold down, Alt, Control, and Shift. Here, I'm assuming you're working on a Windows laptop or computer. The keyboard shortcuts might be slightly different if you're on boot camp or something, if you need to map keys around on your Mac or something. But basically they're as follows. If you just middle mouse alone, you'll rotate around a point. Alt, middle mouse, roll around the camera, and then Control, you'll pan around. Shift, you'll zoom in and out. So we'll see here. I got some weird part. This is a part I worked on a couple years ago. Ignore the big handle at the bottom. That's just a test thingy. And ignore the stuff at the back. It says robotics upside down, and that's a picture of a frog. We'll just talk about navigation first. So I'm here pressing down the middle mouse, and notice I am rotating around a point. Depending on where you click the middle mouse, it will rotate around the point you select. So notice how little, it's hard to see, but there's a little pink plus sign right below my cursor, which is currently a blue arrow in a circle. I'm rotating freely around that point. If I select a different place in the bottom of the trench, then I'll rotate freely around that point. So depending on where you click middle mouse, you will freely rotate the camera, orbit around it if you might, at a different location. And then just to show off some other modifier keys, holding Shift and middle mouse zooms in and out at the point. And Control pans around, useful tool right here. And Alt rolls the camera. Oops, did I press Alt? I am rolling somewhere really odd. But yeah, it is rolling the camera around an axis. Yeah, so having these modifier keys at hand, Control, Shift, and Alt lets you do some stuff really nicely. Okay. Of course, you can always just do the middle mouse, shake things around, and eventually rotate your camera. So now we are upside down, but try not to do this too much because it gets yourself motion sickness. At least it does for me. So try to use Alt to roll the camera when it does work. It's not working for me that much because I think I have something way off screen, which is messing up the rotation. There, Control, Shift, and Alt plus the middle mouse let you get around real quickly. And then here I mentioned middle mouse on the surface once, then middle mouse, click and drag. So rotating around the points and rotating around the axes. I think there should be a way. Yes, yeah. So middle mouse is very versatile. It's not just click and hold middle mouse, but also like middle mouse to set an anchor point and then rotate around the axes of that thing. So here I'm setting the anchor point on the surface or side of this cylinder, you might, and then you can then rotate around the center axis of that cylinder. So it's pretty funky stuff. A lot of tools and a lot of depth to it. You can always read up in the help documentation. Well, it is kind of thick and I don't really like looking through it, but there's a lot of good stuff in there too. So that's just a little bit about navigation. For the most part, I just tend to do middle mouse, move around, zoom in and zoom out somewhere else. But the keyboard shortcuts always good to know because it helps speed up your design process. And I also recommend, if you can, you might want to follow along. If you have some other parts that you've designed yourself, you can pull those up and see how these tips and tricks we're teaching you here might apply to your own stuff. That could be something to do. Okay, so navigation. There's also on your mouse, there's probably 3 buttons, or maybe 5 or more if you're got something more fancier. But you have the left click, the right click, and the middle mouse click. So the left click, pretty self-explanatory. Just click and select stuff. Middle mouse, have you seen just before? It's for navigation, rotating, zooming, panning the camera. Right click lets you open up the context menu, and depending on where and what you right click on, the menu will change. And you'll see here, we talk about a couple different points here. The most important ones that I find using myself the most often are the normal to button, shown by this little guy up here. It's a little square laying flat on the ground with an arrow pointing straight up, perpendicular. That is a normal to button. So if you click on a face, a flat face, and then you right click, you'll see there's a normal to button. Just lets you put the camera normal to it, of course. So facing straight at it, pretty much perpendicular. So that's a neat tool to do. If you want to look at something real quick, but don't want to like maneuver the camera fully, or if the thing does not align like flat against one of the quick views. And the keyboard shortcut I'm doing right here is pressing spacebar to open the quick view. Lets me reorientate the camera to one of the presets very quickly. But if the surface you want to look at is not one of those, then you can just right click on something, normal to. That'll let you maneuver the camera very easily. Okay. And then the other tools I tend to use very often in this right click menu is like suppressing stuff or hiding stuff or making stuff transparent. This is more useful in like big assemblies with multiple parts in it. Like if you got like a wheel or something and an axle, or if you got like a box with stuff inside it, you might want to make the lid transparent so you can see inside, or you can make the whole thing just suppressed and make it disappear. But the differences between the 3, they're a little bit more complicated depending on whether you use it in an assembly or in a part. Or I believe you can also use it in a sketch, but that's kind of complicated. But for the most part, you'll be wanting to use transparency and hiding stuff, that is. Suppressing can cause some weird stuff. Suppressing is like rolling back a feature. So we see here on the left sidebar, we have the feature manager. And we see here a historical log of the things I make and the things that they depend on. Things at the top don't depend on anything. Things below them can depend on stuff above it. So you also see here the rollback bar. When you drag it, it lets you remove stuff temporarily for a while, rolls back the history of changes you made until the point you drag it to. So I've just dragged it back a lot. Let me drag it back some more. And now I just got a square, or rather a rectangular prism. So the rollback bar lets you suppress things historically. You can also just suppress things straight out by right-clicking on it, clicking on the suppress button, which is the cube transforming into the transparent cube. Let's you suppress a feature. And then once again, it's grayed out. It's like as if you have rolled it back pretty much, except not quite. Because you can suppress something in the middle. When you roll back via the bar, you get to roll back everything below the bar. But when you suppress, you can choose to suppress a single thing, such as just this mirror, this mirrored feature. So now the right side of this little device has been removed or suppressed for now. So suppressing stuff can help you see what's underneath, but be careful because if you suppress something up here, like the first one, then since everything else depends on it, everything else has just gone away. So be careful what you suppress. It might cause a chain reaction. Oh man, I should not have suppressed that. Okay, so now you're seeing something that happens when you touch something you shouldn't have. Okay, continue, ignore the error, please. Okay, I'll fix that later. Good thing I made a save copy. Okay, for the most part, you probably want to be using like transparent and hide because those are like non-destructive, as you just saw. It won't blow up your design if you suppress something incorrectly. So, and hence the name, hide will just hide stuff. Transparent will make it semi-transparent so you can see through it and see what's underneath. And those two buttons are via the right-click menu, and you'll see here, suppress, and here is the hide button, the eye with the cross through it, and transparency is down here. You tend to be making, see here, it says face, change transparency. So you'll be making this face transparent, and you can see inside the face. So now I can see inside this hexagonal, not prism, but shape. So I can see inside it. So that is the change transparency. You'll mostly be wanting to use change transparency on like a singular part in a large assembly to like see what's inside the box, see what their circuit board is inside the box kind of thing. So you'll be seeing that most of all in there. Okay. So as mentioned, here are the three buttons. They're often here at the top bar. The suppress and the normal to button are often up there, as well as the hide button. But the transparency button, depending on whether you are in a singular part view or a multiple part assembly view, the change transparency button might be down here to make a singular face transparent, or might be up here to make the whole part transparent. So be sure to look up here. If you don't find it up here, look down there in the face. Okay. And one last thing from me, navigation. So I tend to forget where stuff is. If I forget where stuff is, I always just go to the search bar up here at the top. Nice and handy. So if I want to know where sketches are, type sketch, and then it will show me where it is. And how handy, if I type sketch again, you can either click on it to execute that command directly, or click on the eyeball to show me where it is. It puts my mouse over it directly, and it shows me a big red arrow. You literally can't get lost with this, so I like it a lot. I forget stuff, there's a lot of buttons, so don't forget to use the search bar in the top right. Okay, so I'm gonna probably hand it over to Naomi for the next one, so that I can fix my thing I broke. Okay, so Naomi, do you wanna take it over from here?
Yes.
Thank
Okay.
you.
Let me attempt to screen share. Okay. So we're gonna go over smart dimension. You're usually gonna use smart dimension in a sketch. So let me just, I'm gonna make a sketch, which is important. So here's my rectangle. I want to dimension this. Go like that. Enter a number. It's pretty simple. So you can use it to measure lines. You can also, you click to exit, and then if you want to measure an angle, what you do is you go to smart dimension, you click one line and then the next, and that's how you measure an angle between the lines. Oh.
Yeah, so just to pop in, that little thing popped up there because when we were making those lines, it snaps to guidelines are like 90 degrees or 45 degrees away. So when you click and you snap it to a guideline, it will automatically say, hey, that's 90 degrees for you. And then, so if you then try to define the angle, it will then ask you, hey, do you want to have the dimension you're adding in right now be the driving force to say, this is the angle you're at? Or do you want it to say, for reporting the information, this angle is already at 90 degrees kind of thing. So what we're seeing here is that little window. So because we snap to the guidelines of 90 degrees, it's asking us, do you want this new dimension to define the new angle? Or do you want to say, report out what is the angle between these two? Driven versus driving.
So be careful when you're making a sketch of relations, because they can cause your sketch to become dimension driven, which is not something you want. So I think smart dimension is probably something you all know about. So, I mean, are there any questions that you guys have about smart dimension? No. Okay, I guess one cool thing about it is that you can actually use it outside of the sketch. So
yes, under the sketch tab, you can use it outside of a sketch and it will show up right there. So you'll see shortly how it goes.
So it works pretty much the same. You just select two things and it'll give you an angle, or you can select the distance between two lines and it'll give you a distance. Or if you select a single line, okay. Okay, it works a little different, but yeah, if you select a single line, it'll measure a distance. So I would caution against using it outside of the sketch because it works a little differently. Like here, when I tried to select this line, it selected the face. Also, most of, if not all of your dimensions should come from within your sketches. So be careful if you're ever using smart dimension outside of a sketch.
Yeah, so I got the thing I broke earlier to be fixed now, just rolled it back to an earlier version. So yeah, that was good. Okay, so let me go ahead and I'll share my screen again to show you what's up next. So I want to talk about patterns and mirrors. So these are two important tools when you're making a sketch to like cut down the amount of work you do while also making sure that the work is like consistent. So linear, circular symmetry, symmetry around the points in a circle versus symmetry like along a line or across an axis or a plane. So these are two important tools, patterns and mirrors, you can use in your sketches. You'll find them here at the top in the sketch tab to the right, mirror entities, linear sketch pattern, and also within the dropdown of sketch, you will also see, if I can open up an example. Let me see, I think it was under this one. Yes. So let me open up this example. You see here under the little drop-down arrow, you can choose a linear sketch or circular sketch. So let me just show you how I've used it in my design right here. So I've used it here. I have here a big circle. I also have a couple small things of the 4 cardinal directions, northeast, southwest. And it's little, basically a trapezoid kind of with a rounded center. The goal of this design was to hold a camera in it. The camera points outwards, the cable from the back feeds through the small little trough out the front. And then we encase the whole thing in epoxy to make it waterproof while also being able to still see out. So this is for the underwater robot. So the important part in here was the linear sketch, rather the circular sketch pattern. So circular sketch, I chose this little guy up here, little trapezoid, and then made it a circular sketch, circular pattern around the center point. Let me see if I can show you where that pattern is. Yeah, so here I'm going to highlight it. So notice here, it is pattern number 0. Let me edit that pattern. And so you choose the point, or sometimes also a line or axis or plane about which or across which you want to make the pattern. And then you choose how many instances with the number here. I can choose fewer or more. 3 will make me a triangle within the circle. 2, just the north and the south. But I'm going to choose 4 because I want 4 of them. You can also choose a lot of different options, a lot of things here. Most of them you can ignore, but some of the important ones are the number of instances, degrees you want to rotate around. So I can do what, 4 split across 360 to make 90-degree increments, or I can do something else. I don't know, like 4 across 180 to make what, quick math, 45-degree increments, I think, and then as well as more. And then so degrees, instances, point around what you want to make your pattern, as well as the entities with which you want to make your pattern. So this is also very important. I selected basically the trapezoid right here. It's consisting of like arcs and lines and stuff like that. You can also choose to skip certain instances by selecting them here. I believe it works. It might not work because I already made the sketch. But you can choose to skip certain things in the pattern. So if you want to make like only 3, but haven't made it in a T shape, like 2 across, 1 at the very top, but nothing at the very bottom, you can choose to skip a certain one or certain couple in the pattern, and then it will not show up when you hit OK. But yeah, so that was circular patterns. It's useful making stuff around a circle. You can also do mirrors. It's a very similar idea. You choose stuff to mirror, and then you choose what plane or what line to mirror it about, and then it will mirror it for you. You probably want to select copy. If you don't select copy, then instead of mirroring, having 2 copies at the very end, it will mirror it across, but it will move it from one side to the other, but flip it across the axis, of course. So click and check copy unless you know what you're doing. Okay, so that was circular patterns, mirrors. There's also linear patterns. Oh, linear patterns is pretty fun, actually. Let me go into more depth into that. So linear patterns, let me go out of this sketch and show you something else. Down here, I believe, I think I have a linear pattern over here. Let me see. Yes, right over here. Let me show you this. Okay, so in this, I wanted to have a linear pattern of holes spaced evenly going down the sides. So I can mount it via screws pretty much anywhere on a robot. So to do that, I just did a linear sketch pattern. So let me see if I can show you the pattern and edit this. Okay, so linear sketches are different from circular sketches and mirrors, not only in that they're, of course, different linear instead of circular or cross an axis flipped, but you can also specify multiple different axes to make your pattern. So not only just like one line, but you can do the x-axis and the y-axis to make it like a square of replicates. So it's pretty neat. I chose to only do one axis, so it's going in the x-axis left to right, 1 instance. So it's only 1 column in this table pretty much. And then 9 down, spaced evenly 10 millimeters. So that just makes it 1 column by 9, 10 millimeters spaced apart, center to center of holes. And I chose to duplicate these 2 circles, and then they just go all the way down. So you see here, nice handy 9. Yeah, it shows up right there. So useful if you want to space out a bunch of different holes in your design. There's also some other tools you can do to make holes. There's the hole wizard in the feature tab right over here, but I don't tend to use that much. We'll go over into more depth, I think later today. But yeah, I tend to just make them manually. Okay, so that was patterns, linear and circular, as well as mirrored. There's a lot more options than you need to do on all of those options. You can like check a bunch of different boxes and a bunch of different values. But in the end, you only need to focus on a couple, like how many instances do I want? Until when do I want it? Stuff like that. And of course, which instances of the sketch do I want replicated? So just be sure to, when you do these patterns, look at the left sidebar and see how many instances, how far apart you want them, etc. Okay, splines. So I hate splines. Splines are neat, but they're not very useful for what I tend to make. Okay, so splines are basically, I can never pronounce this right, but Bezier curves, pretty much. You're basically making a bunch of curvy lines and you're dragging stuff around to tweak how much they curve. So there's a nice handy spline tool. They're useful to make like curves, ergonomic stuff, as well as making paths for extrusions, for swept extrusions. We'll go over those later on. But splines are annoying to do, to say the least. So I have here a spline. Let me show you where the spline is. That is a spline right here. Notice here, it's only a very simple 2-point spline. I got here the top edge. I can tweak how much it rotates via this angle thingy right here. And you'll see here the yellow preview shows me how the end product is going to turn out. Because I have a swept extrusion, a hexagon being swept across this. Did my SolidWorks just crash? Okay, no. Okay. I don't like splines, as you can tell. Okay, so you can tweak these depending on the length. It will define how far the curve goes. I don't know how to mathematically explain it, but you just press these things. You can also, you probably want to use the left sidebar and modify the angle normally to say, I want this to be horizontal or to be 90 degrees, and then it will fix it. You can also add more points if you want. I think if I click that, oh, nope, that's not for more points. That's selecting which point to edit. But yeah, you can do these to make splines. You'll often use these for extrusion paths, as you see here. This defines the path that this hexagon will extrude along. Notice how it centers in the center of it. And then when I exit the sketch, it will build it. And now we have a weird hexagon prism noodle coming out of my 3D print. So splines, useful for ergonomic stuff while making nice curves, but they're hard to get a handle with. They're hard to tweak, and changing one thing tends to change the whole thing. So it's a bit of a hassle to use, but they're nice to use sometimes for making ergonomic stuff or handheld stuff. Okay, text and images. This one may be very useful for you guys actually, especially if you want to add like your team name or like a team logo to something. I'm not sure how images will affect how the print comes out. I haven't looked into that a whole lot, but text, you can use those pretty much as any other sketch. So I have here at the back of my design, my good old Froggy and robotics. So that is sketch 16 here. So let me see. Sketch 16 contains a picture. Yes. Okay. So when you have a sketch, you can add text. Let me show you where it is. I can even select it. Okay, edit sketch. And here you see the big A, add text. You type in what you want. You can do a bunch of funny stuff like making it italics. I think also bold it or also rotate. It's handy to use. Click these, just click these buttons. So if I say hello, Froggy, and then I rotate it a little bit, it rotates. Is it going to rotate it? Yeah, rotate it by 30 degrees each letter. So I have hello, Froggy, rotating 30 degrees each letter. Okay, that's very good. So these text can also be treated just like any other sketch you make. It can be extruded or cut into a surface. So you can pretty much like imprint your team name onto a part. You're going to print it, and it's pretty neat. So we can go ahead and do a little test extrusion. Okay, let's see if we can extrude a blind. There's 5 millimeters. Let's not go crazy. Okay, yeah, so hello Froggy has just been extruded. I don't think the Froggy image got extruded, unfortunately. I really wanted that frog to come to life, but you can extrude or cut text into a surface. So useful thing for branding, if you're gonna print stuff or just writing your name on stuff. Of course, do be careful of how this might affect your 3D print later on. we'll go into later on. We'll go into like 3D printing orientation, overhang support structures, and materials as well. But be careful of making a lot of detailed small features, because that can complicate the print or make it unstable. Okay. So text and images, neat things to do. Okay. Do you want to go into this one, Naomi? Relations? If you want, I can also go into this one.
I can do relations.
Okay, thank you.
Okay. Sorry, I gotta get my screen ready to share again. Okay, so relations help you relate different things in your part. So like before, when I made this, when I snapped this line here, it created a horizontal relation between this line and the coordinate system. There are also all sorts of relations that you can add. So if I click this line and this line, there's this list of relations down here. Horizontal relates the line and the coordinate system in SolidWorks. Vertical relates the line and the coordinate system in SolidWorks, but vertical. Perpendicular relates the two lines and makes them perpendicular to each other. They're all pretty self-explanatory. Equal makes them equal, and fix makes it so the lines don't move. So you have to be careful when you're adding relations not to add too many, otherwise you can make it dimension driven, like I did when I did this. Otherwise SolidWorks yells at you. So I can't find the part that Jack's working on, but I can look at a different part that I have. So this one's similar to Jack's. And here we have these holes. So I can add my sketch on here. A really useful relation is to make my circles concentric. So now if I click this one, and to select two things, you press shift while you're selecting them. They have the concentric relation. So their centers are at the same point. And that is really useful for making holes and other circles. Let's see. That's pretty much all there is to it. Oh, one more thing is, if you need to add a relation to something and you don't have the other thing that you need for the relation, you can make a center line. So let's say you wanted something to be vertical to something else or horizontal or something. Center lines are useful for just creating that relationship when you don't actually want the line there. Or if you want a point there, then I can make my circle right there. Yeah, that's how to use relations.
Yeah, let me also show, if I can share my screen real quick, some other cool things about relations. So there is a important tool you guys will want to know about when you're doing relations. So let me show you a sketch. Let's try this one again. So this is very similar to the one Naomi was just showing. So we have here a bunch of circles, and Notice the black one, it is lots of stuff coming out of it. It's fully defined. If I click and drag on it, cannot move at all. It's like fixed in place, can't drag it around. But the blue stuff, that means it's not fully defined yet. So you can click and drag on it and it will move it around. And that's usually no good. Usually you want things to be fixed into place by defining stuff. So I could fix this one by just like defining a length between here and here to define this is the length between each occurrence of the pattern. I'm not going to do that. I want to show you guys an important button here is the display and delete relations button. Now, this one is super important because if there's stuff broken in your sketch, broken as in worse than having a blue, then it will show up here, usually under like dangling or one of these other categories. Here it says dangling, over defining, external, defining context, etc., or broken. I think broken ones turn up highlighted in red. So broken and dangling are the two common errors you'll find in your design. Dangling occurs when you, how do I explain this? When you have something here related to another feature. So for example, if this guy is like 5 centimeters from this edge, but then I change this edge to be like a rounded edge using a fillet, then it's left dangling because the other partner in the relation between the center of the circle and this edge is no longer there. So it's dangling. One thing's still there, other thing's gone, dangling. There's also broken. I don't think, when's the last time I saw a broken relation? Well, when it's broken, it's like really broken. So you gotta fix it or delete it or something. Broken, I think that usually occurs when they're both dead. So when both sides of the relation are dead, it's just like an orphan relation, I think, kind of. Or the relation is illegal. Like you can have certain things. You can have two things that will define something. Like you can have a length. How to explain this? But broken, delete it, make it again, pretty much. But yeah, the blue underdefined does not show up in display relations because there is no relation here. So there's no relation to show up in the list for you to fix. It just means this is not fully defined. You can still drag it around. It's gonna move everywhere. Okay, so display relations is super important for when you want to diagnose what's wrong with your sketch that won't let you like extrude it or something. So useful tool to use when you're looking at relations. Okay, so I will also head up to sweeps. Oh, I showed you this guys already. Okay, so sweeps, let's go ahead and take a look at this. So I already showed you how a spline can be used for a sweep. You do not need to use a spline for a sweep. You can use like, I believe just like an arc for a semicircle, like a 90-degree arc or something, or you can use like a straight line path, a link of straight lines to define the path for the sweep. Sweeps will basically just extrude a cross section along a path. So you can define it to be a curvy path like this, or define it to be like a number of straight lines. Either way works, but curvy paths look nice. So it will ask you to define the cross section. Here it highlights the circle and also the path. Notice how the path comes out of the center of the cross section. I think that is one of the requirements for it to come out the center of the cross section. So the way to do this is the first step I did was I made a hexagon on this face. So that one was easy. I make the cross section super easy. For making the path, I need to make it 90 degrees from this face. So to do that, I made a sketch on the, on the front plane, I believe. So I click here, eyeball, show the base planes, primary planes, and I made a sketch on the front plane. So that way they are 90 degrees. And I also aligned the cross section to be intersecting with the front plane so that when I make the sketch on this guy, it is naturally along the center line, just orientate it and plant it in the center of the hexagon. That way the path is coming out the center and the pipe can be extruded. Okay, let me hide those primary planes again. Okay, so sweeps are nice, but they're tough to use, especially if you use splines. I don't think I've used it all that much. We used it once or twice in robotics because we want to like make mock wires for our ROV, our underwater robot. We need to have a tether going from the surface of the pool down into the robot, and that wire is of course curvy. So we curve it down and then around a little loop to make sure that the strain relief is okay on the robot. I would pull it up, but it takes a minute to boot up. So you can use splines to like guide cables in your assembly, useful for that. but there's also other tools you can do for cable routing in SolidWorks. Make your design look really nice while also simplifying the design. So we'll show you cable routing, I believe, tomorrow. I think it's under the electrical package. There might be also another plugin in SolidWorks that lets you do cable routing easily. Okay, so that was sweeps. All right, you can find sweeps here in the features tab. So swept boss or base. You can also do the reverse swept cut. You can make the path inside the object, you can cut it. Same principle, select the cross section, select the path, cut along the path. Pretty easy. Okay, just guidelines for sweeps is it must be perpendicular, it must come out from the center. And then those are pretty much the two guidelines for sweeps. Aside from that, pretty straightforward. Fillets, okay, this one's pretty fun. Fillets are basically smoothing out the edges. You want to buffer the edges, make it easy and not going to scratch you up when you hold it. So these things are super important. They look nice, they feel nice, and they cut down on waste. They're also cheaper because you need to use less printing stuff. Usually, that is. If you make the fillets where you shouldn't, then it can make you not save as much because you might need to like 3D print some support structure so you can build or print your cylinder or whatever it is now. So yeah, if you make too many fillets, it can cut into the strength of the object and make it weaker. So you see here, I have a couple of fillets. Let me see if I can show you this guy. So this guy, if I suppress this, I think it won't blow up. Yeah, so right now I got a rectangular prism. If I try to hold this in my hand, hard edges, it's okay, I guess, but you can save some space, save some 3D printing filaments, and just make a fillet. And there we go. So pretty nice to do. And it's super easy. Under Features tab, there is the big fillet button next to the linear pattern. You can also make chamfers. Chamfers is just like making a straight up cut along the corner or edge. So if I make a chamfer along this, and it's not showing me a preview because it is assuming by default that you want a 10mm chamfer. So I'm asking for a full preview. I want a 1mm chamfer. And then it will trim the edges. So now I have a flat cut along all the edges along the bottom base. So yeah, chamfer, fillet, they both function very similarly, as in the buttons used to operate them, very similar. You select an edge or one number of edges, select the depth, and then it will cut it for you. So fillet, rounded, chamfer, straight cut. Nice things to use, make your design cheaper a little bit, and also easier to hold. Okay.
Something I want to add is that if you use them correctly, they can also increase the strength of your part. So say if you added it along this 90-degree angle.
Oh, do you want to share your screen or do you want me to do something?
I can just circle it right there. Okay. If you added a fillet there, it would increase the strength of that angle.
This one right here?
Yeah, adding a fillet there because it would have more material, and so any force along there
That's a good point.
It would distribute it.
So fillets not only cut, but it can also add material. So let me see if I can normal to and zoom in. Okay, so I tend to use fillets mostly for cutting stuff, but you can also use it to round inner edges. So fillet or chamfer, and then it will show you, hey, do you want to add some material here? And then click on OK. And now we got a rounded inside edge. So really nice, yeah. And as Naomi said, fixes something up, make it stronger, and looks nice as well. So that's fillets. Hole Wizard, I'll go over this one. Hole Wizard, I mentioned it before a little bit, helps you make holes a lot really easily. So instead of doing it manually like I did for this one, you could just click on the Hole Wizard button right here at the top, and then a bunch of different buttons come up. A lot of buttons come up. It tells you which type of hole do you want, recessed hole, straight up on the top, how recessed do you want it, how wide do you want it, how many edges of the recessed hole do you want, there's a lot of options, and I tend to get overwhelmed, so I just make it manually. But I'll just choose the first one, recessed hole, and I'll just choose up here. Let me see, I gotta select the standard using. I'm using hex screws, I'm using M3 hex. I want to go through everything, and that sounds good. Click on OK, point on the face. And then you select, here's a hole, here's a hole, here's another hole. So click the holes you want, and it makes it for you. Ta-da. Yeah, so hole wizard, although it kind of seems to have broken. So I don't tend to use it, I just make it manually. But hole wizard can be your friend sometimes, especially if you're just making it in simple materials, or rather simple faces that are not like a bunch of different things underneath them. So this guy has a bunch of things underneath it. That's why it's probably breaking. So hole wizard's there if you want to use it, but I just recommend doing it manually. Okay, and I'll pass the mic back to Naomi for reference geometry. This is also super important and makes your design real nice.
Just one more thing about hole wizard is that you can use it to add threads to things, which isn't strictly necessary because you probably don't want to 3D print threads. It usually doesn't go well, but here's a part where we did create threads using the hole wizard. Yeah, just wanted to show that off. It's not too hard. Let me try to find it. So in features, hole wizard, then you go to thread. And it gives you this warning not to use it. And then you just select a surface like that. Like you select, a circle. And then you select what size. So we typically use M5 or M3, and then you can create your threads. So it's pretty easy to use.
Yeah, and as you might expect, it's not recommended to print out threads because they're really small details, and structurally, when you print that thin, it's not gonna be super strong. But you can still try to do it. It's hard to print because it needs a lot of support structure to print as well. If you try to print it like, I don't know, flat on the coin side of this little coin, it's not really a coin, but flat on the circular face, and you try to print it, then it will need some support structure usually between each of the threads, each level of the threads. So it'll take a lot longer to print and also not come out very nice. There might be some gunk even after you chop out all the support structures. So printing threads, not recommended usually, but there are ways to do it if you want to do it really. So reference geometry.
Okay, so for reference geometry, this is something that happens outside of the sketch. So it's right over somewhere over here. There it is. It's hidden since my screen is smaller than usual. So you can use it to create all sorts of things, planes, axes. And these are typically more useful once you're in an assembly. But let's say I wanted to create an axis. So you have to select something for SolidWorks to use to like mathematically create the axis. So I'm gonna try selecting this circle, and I selected the face. But so it used all of that to create this axis going this way. Good, good. So now I have my axis and I can use that to do other things. So a part where I actually use reference geometry a lot is, let's see if I can get it to open. This. So I wanted to create these little offshoots and holes at different angles. There are so many planes that I can't even see these. Okay, yeah, there's the hole. So I didn't want this hole to go straight down. I wanted it to come through at an angle. So I created this plane for it to come through. And I also created this plane. We needed these at a specific angle for some specific geometry of the part. So I had to create these planes using specific things. And if I edit the feature, it'll show me what different things I used. Oh, this is just a duplicate. Okay, plane 3 is the one I want to look at. Where is it? Okay. So to define a plane, you need 2 lines. So I selected this line, and it created this plane at this weird, funky angle. I can also create a plane using, you can use another plane. So if I select this surface, it'll create a plane, and the default offset is 10 millimeters, but I can make it anything. So I can make it 60. And then my plane's way over here, and you can use this flip offset to make it go the other way. I can also, can I make multiple planes? Is that what this button does? Yes. Okay. So if you need to, you can make multiple planes. You can switch the relationship. There's a whole bunch of different reference geometry. But the ones that I typically use are plane and axis, sometimes point. The rest of them, not so much.
Okay, let me go and share my screen again, and we can talk a little bit more about one of the things I'm really good with is configurations. All right, before I go into configurations though, I wanted to talk a little more thing about reference geometry. Reference geometry is super important for when you're making pretty much anything, because you will want to say, I want this hole to be like within these 2 points or in the center of these 2 planes, whatever. But reference geometry, when making planes, you have seen on Naomi's screen, there's a lot of different options here. You can have up to 3 references. Most of the time, you only need 2 references, but sometimes you can need 3. So if you just select one plane, you say, I want an offset from this plane this much, or you can select 2 opposite planes, it'll give you the mid plane. So play around with these, and you can get a bunch of different weird combinations that will allow you to define where the plane is, where there's intersecting stuff, in between 2 stuff, intersection of 3 lines, whatever. But there's lots of different ways you can do reference geometry. Okay, so let me go back to configurations. Okay. So configurations are neat. They let you basically make multiple versions of the same parts within the same file. Just gotta flick a switch and then changes the whole part for you. So I have here, you notice here on the slide, I got 1, 2, 3. There's actually 4 different configurations, but I didn't show the 4th. But there's 4 configurations for this single part. It's all under the configuration manager. So let me see. Here we have on the left side, by default, you're usually on the feature manager, but there's also property manager and the configuration manager, among others. So configuration manager is where you go to manage your configurations. You could just like copy part, make it tweak slightly and put it somewhere else. And that's another configuration, yeah. But the trouble with that though, is if you want to make a change that affects them all at the same time, then it is very difficult. So for example, if I accidentally made this length too short, then I would need to go into each individual file to change their values manually. Or later on, if you want to get fancy, you can use global variables. But well, let's not talk about that for now. But we will go over configurations. So I will show you different configurations for this guy. So we have base mount facing down. So it's just a mounted flat, looking straight down. We have belly mounts. So on the belly, 45 degrees angle down, and belly mount forward with the frog in the back, of course, very important. And no mount, the testing prototype model, just to see if it works. So let me show you here. Okay. So these guys here, these are all shared. This is the base model pretty much of the design. And these features are all shared between all of the configurations. But each of the other configurations uses only stuff in one of these other folders. So you can add stuff to folders, just click on it, right click, add to folder, or just drag and drop. But when you make configurations, you usually want to right click on the very top, right click, add configuration, and it gives you a bunch of options. Just to give it a name, 1, 2, 3. And important stuff here is this one, suppress features. Usually you want to click on suppress features. Otherwise, if you don't click on that, then changes you make in other configurations will probably affect the stuff you make in this configuration. So suppress features, and then it should be good. Okay. You can also make sub configurations. Let me see if I can delete this one. Does it let me delete it? I gotta select something else, I think. Delete. Let me see if I can show you a sub configuration. Add derived configuration. That's basically a sub configuration. It is based on the parent of it, but can also be suppressing other stuff. So let me just take a look at the properties of this configuration. So I have suppressed features. I have a bunch of different stuff. But if I were to make a change in the, let's see, the length, I think, of this guy should be good. 95, let's change it to, I don't know, 195. Then it's pretty much double the length right now. And if I go to the other guy, I think I should fix it. Yep, so now they're all changed to 195. So if you change a shared value between all of the configurations, and they're all changed at once, one flick of the switch, they're all changed. So nice thing to do when you have multiple similar parts is to just make configurations of it. And then that way you can change them all very conveniently. So just be sure to check the button for suppress features, and you may need to do some wiggling around. Let me see if I can show you what I mean by that. So if I go to properties here, and I think it's under custom properties. Was it not? Dang it, there was a way to specify preview properties. There was a way to manually specify which features were or were not excluded or suppressed. I forgot where it was. I think it might be an assembly view only. That's annoying. Okay. Apply to, no, not. Okay. So configurations, useful tool for making a bunch of different similar objects, which are slightly different, or making a single change to multiple objects. So keep that in mind. Okay, and then global variables. Okay, I'll pass this back to you, Naomi. I'm not very familiar with this one, but Naomi is a pro at this.
Okay, so global variables. These are useful for defining measurements in your part file. Instead of using relations or linking things, this makes it less likely for you to get that SolidWorks yelling at you that your part is overdefined, or that you know, when you have to change something and you have to go through and change every single little number because you didn't do one measurement right. So yeah, we've been there. Let's sketch here. Okay. Why is it not? Let's sketch. Okay, we're in business. So to add global variables, you go to tools, equations, and then they're going to pop up. And so I've already added some global variables, and I'll show you how to add some more. So you have to type it as a string. So I'm going to add my quotation marks, and then I'm going to call this one, I don't know, you can call it anything. We'll call it cat. And then the next part, did that do it? Yeah, the next part, I'm going to type in a value, we'll say 4.5. That's all we need to do. And then it's done. And for comment, I will say yay. So there's our variable. And the cool thing about global variables is that you can make them composed of other global variables. So let's say I have the international keyboard and it's really annoying. So let's say dog, and that will be cat. Oh no, you have to, when you type this in, you have to use the, what do they call it? Quotation marks. Okay, so that'll be equal to cat times banana.
It's a really weird variable naming choice.
I know, I should have named these better things.
No, it's good, it's good.
Okay, so now you see that it took the variable for cat, which was 4.5, and the name with the thing for banana, which was 3, and it multiplied them together for me so that I don't have to do the math, which is good because I'm really bad at mental math. And we found it's 13.5 inches. And we don't need a comment. So we're going to say, okay, so we have our global variables. So now we're going to go into our sketch and we're going to use smart dimension. And we're just going to dimension it. So we go here, we click, and now our global variables pop up. So we can choose from any of these. I think we're going to make this one cat. And then we check mark, and we have that dimensioned, and we can do the other one. And we go to our global variables tab, and I want to make this interesting. So I think dog and banana were linked. So I'm going to make this one. Actually, I'm going to make this one A. Okay, this is A. Okay. And then we're going to say good, and then I'm going to exit. And now we're going to go to features and extrude. And I want to extrude this by global variables. I'm going to extrude this by banana. Okay. So now it's all defined. It's all defined by our global variables. But let's say I made a mistake. I measured something wrong. The calipers were broken. So now I can go back to tools. I can go back down to equations, global variables, and I can edit them. So let's say I got A wrong and it was actually 4. Now all of these change. So now A is 4, B is 4, and dog is now 18 inches, okay? And our part has changed accordingly. So I can go to.
You need to rebuild first? I'm not sure if it does for you.
I think I do need to rebuild. Where's the rebuild button?
As you see in the top bar to the right of the file edit thingies. It might be hidden because your window's not large enough. If you maximize the window, I think it shows up.
Okay.
Yeah, it's a little stoplight to the right of the pointer at the very top, next to the part name. Yep.
Okay, it should be good now. So now I need to go to evaluate, and we're just going to make sure that this worked. So measure, and this is now 4.5, and this is 3. That is, hold on.
Oh, I think when you entered in the global variable for it, it like evaluated it or something. Because when you enter in like A or banana or cat or dog, when you hit enter, it changed to the number it represented before you on the smart dimension or on the extrusion.
Something's not right here.
But yeah, there definitely is a way to have it linked to a global variable. Why
is it not? Okay. That did not go the way I wanted it to go, but why did it do that? Okay, I'm gonna try to fix that. We can move on while I work out what happened here.
Okay, gotcha. Let me go ahead and share my screen and I will show you. Let me see, I wanted to show you section view. Okay, so this is really nice. Section view is a super important tool. So earlier when I was talking about like transparency or suppressing stuff or making stuff hidden, an alternative to that is just section view. So section view, as you see here, gives you a cross-sectional view of an object. You can use this both in a singular parts or in a large assembly. So nice, neat little button here. It is like a donut pretty much chopped in half, section view. Let's click on that. And it has here a partial cross section already done for me. So you can choose to select here, like I want to cut it in half on these different axes or these different planes. You also just drag on these arrows and rotate it around. Oops, let me rotate it around. Will it let me rotate it? Well, let's be dragging. You can just click on the buttons, I guess, and then have it chop in half that way. So it's a useful tool for looking inside of boxes or looking at inside of complicated structures. Oh, look, Froggy's not chopped off. Okay, very good. But yeah, section view up here is very nice to have and to use for looking inside of stuff, for looking at stuff that's hidden behind stuff. So keep that in mind as one of the tools you'll be using often, especially working with large assemblies, large parts that has intricate stuff inside of it. Okay. So I think I know what's happening with the global variables. Let me see if I can try it here actually. So I went to tools, I went to equations, and a global variable called length. That is a very bad name. Okay, length. Let's have this be 21 millimeters or something. 210 millimeters. Sure. I'll click on OK. And then I think when you do something here, so if I want this extrusion to be that, so I say equals to length. I think this way. Click on the global. Okay, so it should be length now. Okay, so it's 210 now. And notice when I click on it, this smart dimension I made now says equation sign, sigma 210. So that's how I know it's based on an equation that has variables in it. And then I can go back to tools, equations, and I can think I modify it. So I chop this in half, go back to 95. And then it did that for me. Yeah, so the trick was when you are using global variables, okay, so you could just click on global variables, give me the length, and then it will evaluate it at that moment in time as 95. Or you could say equals global variables length, and then it will constantly evaluate it whenever you open up the file. So now it will always check global variables file. Is it 95? Is it 210? Is it 100 something? So be sure to use the equal sign, equals something. If you just type in length itself, they'll evaluate it at that moment and spit out the number. So be sure to use the equal sign. Yeah, so I think I ran into the same problem as Naomi a couple times before. It's kind of hard to get a hang of, but just be sure to hit the equal sign. And if you do smart dimension, you'll notice it has the sigma equation sign or some sign for showing you that it's based on other stuff. Also, one more thing about global variables before we head into a break is that global variables are not just defined up in tools equations. There is also variables based on other things. So you can type in global variables here manually. I want length to be this. Or I believe you can also specify, so it's a sketch 2. And this is, what is this? So this one is called D1 at sketch 2. So you can, this is a variable right here actually. So I believe you can use that. It is 22. Let me see if I can use that in something else. So if I say equals D1 at, I think this should work. I might have gotten capitalization wrong. yeah, so now every smart dimension you make is a global variable. So D1 at sketch 2, now that's the length of my stuff. It's really short now, but yeah, so every smart dimension you make is global variable alongside the stuff I type in manually in the tools equations tab. So some neat tools there. Okay, we're just about headed into a break, like a 10-minute break before we head into our next section, talking about 3D printing. So are you guys okay with us meeting back at 3:20? Grab a sip of water before we head back into 3D printing. Okay, if there's nothing, no questions, we can hold on to those until we get back at 3:20. Okay, so let's go ahead. I'm going to step out for a moment. I'll be back here before 3:20 to answer some questions if you guys have any. So in the meantime, we will see each other again. Okay. Let me go ahead and pause the recording temporarily. And we will meet back in about 10 minutes. Okay, I think the recording is resumed now. Okay, so we are back, and we will now transition into talking a little more about like 3D printing, how we've done it on robotics, what sort of tips and tricks you might want to keep in mind as you design parts, as well as slice and print them in the actual printer. Okay, so just a good luck Froggy right here. We will now transition and take a look at, this is Ultimaker Cura. This is what we tend to use here on robotics. We tend to use Cura. We tend to use like a model price printers as well as Ultimaker stuff. Sorry, not Ultimaker stuff. I forgot what it's called. Was it Model Price? What was that brand again? I saw the tip of my tongue. The brand of 3D printer we tend to use. Prusas, right? We have a bunch of those. Okay, so 3D printing. Okay, so just a general overview of the workflow we tend to use is like we tend to save the part we're working on as an STL file. STL files, they're generally recognized. I think pretty much any slicer can take STL. STL is a very basic triangle-based like file type. Chops up your part into a bunch of triangles, and then you can then open it up in any other slicer. So you probably have heard of like Prusa slicer, Ultimaker, Cura is just like Prusa slicer pretty much. They're all rather similar, I suppose. A slicer is basically a piece of software that prepares machine code, G code, for a 3D printer. It specifies like how hot the nozzle should get, where it should go on the print bed, when it should extrude, how much it should extrude, and other features. So if you're really advanced, you can modify the G code yourself. But for the most part, you can just like put it in a slicer. It'll spit out G code for you. You just toss it in the 3D printer. But if you want to get more advanced, you could look into modifying G code manually. Okay, so back to the workflow. Save the file STL, open it up in a slicer. So I have here, I am on step 2. I've opened the STL file in a slicer. So you didn't see me off screen. I have saved the part as an STL file, and I dragged it and dropped it in here. So I will open it up in here. So let me go ahead and actually go back to the mode I'm supposed to be on. Let me delete this. Okay, so I have here, I just dragged it and dropped it into here, and now I have a large golden part. Let me see if I can. Okay. So a large golden part I just dragged in here. Then the next step we tend to take is we tend to like orient it, and then add more copies if you need more. After that, we adjust the print settings, check the preview, slice it, and save it to a flash drive or SD card, and then put it in the printer and start printing. Okay. So as for using the slicer, most slicers will let you modify or orient the parts you drag and drop into it or open it up with. So you see here on the left side, there's a bunch of different buttons. You can move stuff around, X, Y, Z, scale it up or down, rotate it, and have it snap flat. You can also mirror stuff or make copies, I believe. Or use some funny options. Okay, haven't used these ones before. This is a new version. Okay. So let's say I wanted 2 copies, then I'll do it like that. And then we can have this guy rotate it and have it be straight up like this. And that should be good. Okay, so now that we have oriented all of the parts and we have made the number of copies you wanted, we can go ahead and click on the slice button. Of course, before you do that, you may want to take a look at the print settings. So I think most slices you can select which exact model of printer you're using. So for example, you can take a look at the printers, and this will basically set how large the print bed is going to be. Most printers have different print beds, I suppose. So like maybe a smaller, cheaper one might have a smaller print bed, smaller maximum height set by this bounding box, and so on and so forth. They will also have different parameters, as in maximum speed as in nozzle travel speed and nozzle heat. You can also specify, I think most slices can also specify materials. So you can pop it in there, and then it will, I believe it will then populate the right side with the recommended settings based on the material. So certain materials require higher heat or maybe slower printing. But you can also modify them manually. So important things to consider when you are slicing is, I believe it is, okay, support is important, travel speed, cooling, speed. Print speed is important, infill is important, and top bottom walls quality is also important. Okay. And also material. Okay, so most of these things are important actually. So let's start at the top, layer height. Self-explanatory. How thick is each layer going to be? And it says here on the nice tooltip, higher values produce faster prints in low resolution because each layer is thicker, less resolution, less control over the granularity of each layer, but then again, faster. So prototypes usually want to cut corners, just get it in your hand as quickly as possible. But for actual real stuff you're going to use on a robot, you will want to have more quality stuff, have it print slower so that it will not mess up, and have a higher infill. You can also specify a bunch of other thicknesses, walls, top, bottom. Infill is also very important. Infill determines how thick is the inside going to be filled with plastic. So I think we can set this to 10%. Let's see what happens. Let's check this to a nice, cool gyroid. Never heard of that. Okay, let's slice it and see what happens. So slicing basically changes all the stuff you have manipulated here on the bed, as well as the settings you have here, into G code for the printer to read. It's generating the G code right now. Most slicers can also examine the G code and may give you a preview, as you see here shortly. So I'm curious, I want us to take a look at what's actually happening in the printer as it prints. Okay, so I have here a play button. What the? Is it not going to work? That's no good. Okay, let's try removing this guy first. Let's just do a basic single one. But the preview should show me layer by layer how the printer will move, how it will construct the thing. Okay, yeah, so here it is. Showing me how it's going to build it. Oh, I was on the last layer. That was why. Okay, yeah, I see. It's hidden underneath the zoom screen. Okay, so we will start at the very bottom. And from layer 1, see how it goes. So we're not going to look at this. It's very slow, of course. What you see here is building a brim around the bottom edge. We will see what a brim is and what other support stuff is later on. But you see it slowly builds it up from bottom to top, as you might expect. And the infill pattern, oops, the controls are different from SolidWorks. It is a grid. It's at 10%. So most of it's hollow, 90% hollow, 10% filled. So this is probably good for prototyping, but if you want to have it bear up to any sort of stress, you will want to choose a higher infill. And notice there's a lot of this cyan stuff. all the sand stuff, that's all support structure. Support structure is important so that when you print something, it won't fall down and crush itself. So for example, we need support structure. We want to print holes like this in the side. I don't know why it's asking for support structure all the way up here though. That's kind of weird. Ooh, okay. And then also support structure inside of it because of how we chose to print it, which direction we chose to print it. So depending on how you orient it, it will have less or more support structure. Okay, keep on going. Let's go all the way. Okay, so go print it, 10% infill. And then the red stuff's the walls, green stuff's also the walls. And then there's done. Okay, so we just take a look at this and we see that's a lot of support structure, like almost more support structure than there is actual plastic being used inside the print. So that's usually not a good sign. So let's go ahead and modify that. So to fix that, I'm going to go ahead and rotate it because I don't want this to take a lot of plastic just to print the supports. So I think that this way might cut down on the amount of supports needed because that way it'll just print straight up, except for the long weird path coming out the side. That thing will take a lot more support, of course. So things to consider as you not only slice them here, but also as you design them in SolidWorks or Fusion, whatever, is how is it going to be printed or manufactured? If we're going to be 3D printing it, consider carefully how you're going to print it. Is there going to be an easy print path, stuff to print? Is there going to be a lot of support needed to print this object? If there is, try to cut down on that or see if there's a better alternative. So now it will take 34 grams of filaments and take 8 hours and 40 minutes compared to, what about this? 34 grams at 8.5 hours. $41 grams at 7 hours, 50 minutes. So this takes more material, but slightly faster. So consider that. Okay.
Jack, we have a question on how you insert a file to CNC.
Good question. Well, let me do that. So most of them, they're pretty beginner friendly. You can just drag and drop stuff. So I have here an STL file. Pretty much any slicer, Ultimaker Cura, Prusa slicer can process STLs. You can just go to File, Open Files, and select from there. Or you can just drag and drop for the most part. I just hit drag and drop. And then if I'm going to prepare, it shows me that's the file. You can click on it and modify it, and it should be good. Okay, let me go ahead and drag that gap. I think that might cut down on minutes even more. Okay. Once you do select these options for your printer, you will probably, after like a couple different times of printing, you'll find out, oh, hey, I usually should set a little bit higher temperature than like the manufacturer specifies or something. Or maybe you tend to go a little bit slower on the prints because it tends to be better quality. Then you can set that as a preset and then just share that with your team and then just use a single preset for all your prints pretty much. So that's usually a pretty good idea. I don't know if I have the preset for robotics here. I think I might have. It's been a while since I printed it. Well, that's usually something good to do. Save a preset of your usual settings. I wanted to talk about also, I talked about infill. Infill determines how much of the stuff inside is getting filled up with plastic and what sort of pattern. There's a bunch of different cool patterns, but if you're going to be printing like structural parts, you probably want to bump this up to like, I don't know, more than 60, 70 usually. Daniel, yeah?
I believe I've found octal to be the best pattern for structure.
Ooh, fancy. Octal. Is it octet?
Yeah, it's pretty solid.
I want to take a look at this. It's really cool looking at the slicing. It's like watching paint dry. It's very exciting.
Watching
as we
3D printer print, it's kind of exciting.
As we watch this guy print, let's go ahead and talk a little bit more about the other things we want to take a look at. So printing temperature, self-explanatory. How hot is it also going to get? Build plate. Sometimes I think many, or if not most, 3D printers come with a heated plate. This is important, as in the plate that this guy rests on should be heated because it lets the plastic, the first layer and couple first layers of plastic adheres to it more strongly, reduces the probability of failed prints, and make sure it's not going to move around as you print it. Most of the time, you can specify these based on, like, if you buy 3D printing filaments off the internet, most of the manufacturer will give like a instruction manual of here's recommended options, temperature, build plate, etc. Speed is an interesting one. As you might expect, slower speeds usually results in high quality prints, but you can't just bump it up and be super fast, zoom around, have a higher rate of failure, but also makes your prototypes print much faster. So something to consider as you slice your stuff. Another one is supports. Supports is very important because when supports are needed in many designs, I would think in pretty much most designs, you need some sort of support because you will need to help prop up large overhangs and other things. So support here and build plate adhesion here are some of them. Takes so long to slice. Okay. Okay, here it is. All that cyan stuff is supports right now because I chose a very bad orientation to print it on. And if we go back to brim, so you see here that blue stuff on the bottom on the surface, that's called a brim. It's useful for making sure that the thing adheres to the build plate, especially if your thing only contacts the build plate by a little bit at the very beginning. You usually want some sort of contact with it, but it can take up some more plastic than you want. So you can choose different options, just like skirt and other stuff. Skirt raft just has a chunk of plastic underneath the whole thing. So it's like brim, but like there's an extra layer of support underneath the brim across the whole thing. So the whole thing lies on a raft, basically. Skirt, I never really found these for skirt. I suppose it helps make sure that the first layer, that the first bit of plastic extruded from the nozzle adheres to the build plate. It's just got a test line, make sure it sticks, and then it goes in to build the actual stuff. So skirt can help with that. Play around with these depending on your own printer. See what options work best for your prototypes and for your functional prints. For the most part, though, I think if you go with like the slicer your 3D printer manufacturer recommends, then the defaults for them should be pretty good. I think most of them are pretty much the very beginner friendly nowadays. I think large manuals, a lot of support, a lot of videos, a lot of guides and forums where people discuss what's the best stuff for printing. You can specify some more complex stuff, support placements. But for the most part, if you design your parts right, you can get away with having a lot fewer supports. So if I were to when I actually built this thing, it did not have a humongous like elephant trunk coming out the top. That thing did not exist. That was just for example for splines. But when I did print this, because this thing was 3D printed, it was used on a robot. We printed it like this because that way it reduces the amount of supports needed. If I were to print it flat on its belly on the long side, then there'd be lots of supports inside the cylinder, which would possibly be detrimental, higher chance of failure maybe, or just take more plastic than that was needed. So this way, minimal support. Ignore this red trunk, see if that was like ignored. Then you'll see there's very little support needed. Just a little bit along the edges, make sure the thing doesn't fall over. And make sure you can print in the holes as well. Aside from that, just use a knife. Once it's done, knife, just cut out the holes, chop off all the support plastic, and your part's done. So design your parts with how it's going to be printed in mind. And we'll talk a little more about what I've seen in printing, what sort of things you should keep in mind as you print and as you design. So specifically as you design, consider what face will be on the print bed. Is it completely flat? It's going to have like raised edges, or like curves or stuff, it's going to lift it off the print bed. If there is, there's going to be more support needed then. So consider that as you design your parts. Usually if you're designing a 3D printed part, you want like it to extrude in one direction for the most part, have some details maybe, but not too much overhanging in midair. Otherwise, you will have this guy right here with a humongous amount of skyscraper level support needed. So try to avoid this. It takes a lot more plastic, I suppose, but also a higher chance of failure. Maybe if the plastic gets too heavy or something, or maybe it doesn't adhere right over here, then it could fall off. So, and then your 8.5 hour print has gone down the drain, unfortunately. So try to avoid a lot of big supports needed. Also avoid small or super thin features, especially so for structural parts. After all, it is just plastic. Certain types of filaments and plastics are stronger than others and operate and behave differently based on the environment. But for the most part, you probably don't want to rely too much heavy structural stuff, at least, on 3D printed parts. After all, it is plastic, it can break. The advantage of 3D printed is that you can make it any shape you want, pretty much. Some restrictions, of course, but and it's easy to print. It doesn't take months or weeks to ship to you. But then again, you probably want to stick to more durable materials for larger structural parts. Smaller thin features can't snap off easily. Plastic is brittle. Some plastics are brittle. Certain plastics are not so brittle and can maintain strength even at thin features. But as a general rule, I like to avoid having super thin features that like link two things together, because then they'll snap off even if you just like nudge it or something. Also, you see here the tree trunk, the elephant trunk. Avoid excess amounts of overhanging materials because this requires a lot of supports to prop it up. So yeah, we have like Twin Towers level of supports right here. Do not do this. Disaster waiting. Okay. And that was just when you're designing it in SolidWorks. When you actually slice it here in the slicer, here's when you will get to choose how it's sliced. So first tip I have here is how should the print be oriented to reduce support needed. This way is one way to reduce support, 34 grams total of material, seen here in the bottom right. You could orientate differently. I think this way might be more material needed because we have to then fill this guy up, prop up the big elephant trunk, as well as fill in the internal of the cylinder so that we can prop up the roof of the cylinder. So consider carefully which way is the best. And as you see in the small picture, that way is definitely not the best. We got a lot of stuff propping stuff everywhere. Do not do that. So try to consider which way is going to be the best way for me to prop stuff up.
Another thing to consider when you're orienting the part for printing is which way the force is going to be applied with respect to the layers. So like if you're applying force along the direction of the layers can just like shear apart. So you want to make sure you're applying force directly down on the layers if possible.
That's a very good part. This is super important for structural parts that can be taking a lot of forces in different directions. You want to make sure that, as Nimi just said, that you consider the direction of the print. It's a lot to take in at first, but the printer nozzle moves in set direction. You can see it via the preview actually. So based on the direction of the print, there'll be more strength in certain directions and less strength in other directions. Let me boost up to this layer. It's probably better. Okay, notice how the lines are like diagonal. Oops, yeah, as Nimi was saying, it's probably stronger in forces from bottom left to top right than it is in forces shearing it from top left to bottom right. If you were to have forces like this, it will probably I don't know, start cracking much more easily than if you were to have forces top left to bottom right. It's not super important for this one because this one just holds a camera. It just mounted on somewhere. But if we're going to be printing stuff that's like structural or stuff that's going to be supporting lots of stuff on it, heavy stuff, then you will want to consider what direction is the printer printing it. And if so, how you can game the system is just like rotating stuff. Or if you want to get super advanced, you can see if there's some other options, or maybe even editing the G code manually to modify the print directions. Well, that's tough, but it's important to consider as you print structural components. And as you slice, also consider how much infill do you need. Prototypes get away with like 10%, maybe even less if you're risking it. But 10% around-ish for nice prototypes, fast prototypes. It probably fall apart once you like blow on it or something, but it's just a prototype. So also consider how the print will affect the structure in different directions. Yeah, good point. So is there a better direction based on the forces you expect to be inflicted upon this part? Will it blow up if you force it this way? Will it stay strong if you force it this way? And also, what kind of filament is best suited? So with that, let's actually transition into talking about filaments and properties of materials. So it's just a little, very high level overview. There's a lot more, there's a lot of material on this stuff online, talking about like what's the best material to use or something. The fact is that it's the best one depends on your application. Here's robotics. Since we tend to work with underwater stuff, at least for the mate ROV competition, we tend to go for like PET-G and pretty much only PET-G for 3D printed stuff because it's like water resistant, UV resistant. Other stuff sometimes can get damaged and can like chip off and they have like plastic splinters left in the pool. That's a big no-no. Don't want plastic in the pool. So we tend to go with PET-G. When you are choosing filaments, consider not only like the structure, but also like the temperature of it, how hot you need it to get to melt it. If you go with like a super cheap 3D printer, it might not be able to go high enough for certain types of materials. Certain materials, I think like nylon and like, I don't know, polycarbonate or something, are pretty high temperature, like above 300-ish, I believe. Don't quote me on that. But some of them take high temperatures for the nozzles and need like special superheated beds, like, I don't know, 90 Celsius or more for the beds for it to heat. So consider the temperatures you need and also strength and other stuff. So for non-3D printed parts, for our main robot, for large structural parts, actually, let me talk about that. For large structural parts, we don't tend to do 3D printed for that because large structural, we might as well just like buy stock material and cut it out. Instead of like printing layer by layer, we just chop off stuff. And then there we have a robot. Of course, it's not just like getting a bandsaw and like chopping stuff off. We actually use like large CNC machines. We use what? X-Carve, Inventables X-Carve to cut out parts of HDPE plastic that we don't want. Specifically for us, we use HDPE. I forgot what the acronym stands for, but it's basically water density plastic. So that way it's not going to sink us in the water or float us to the top. But that is a talk for tomorrow. Tomorrow we're going to talk more about CNC stuff and how you might want to approach CNC stuff, cutting out materials, stock materials, and so on and more. Okay, so Q&A. We are almost at time's up. We are at 3:47. I was planning on holding a Q&A near the end to like talk about what we've been doing here at robotics. Maybe if you want to show some of your own guys' stuff off, we can take a look at that, give you some pointers if you guys want. Or we could like, I don't know, show off some robotic stuff, see how some of the tools we've been showing you here have been used in action on the robot and other stuff. How do you guys want to approach these last few minutes?
So I do want to mention it would be important to take a look at the type of structural support that you're using, like the type of like layering. So when we're talking about optic, there are other variations and other types that you can choose for that pattern, and they have varying strength. So definitely I would look into that a little more. It's been a little while since I've printed.
I think, how long has it been for me? I think it's been like at least a year for me since I touched a 3D printer, actually. We haven't been doing much prototyping. We did a couple little prototyping back in the fall, printing some stuff, printing out some 3D bridges. We made some bridges in SolidWorks and then like stress tested them in simulation, checked them out against like how we're going to fare in person and see how how much weight they took before they snap. We did that for some fun back in the fall. We'll show you guys simulation stuff next tomorrow. So that'll be some cool stuff. The simulation stress tests you can do with the simulation plugin. So about the infill stuff, that's a good point, Daniel. I'm not very sure myself of the relative strengths between each one. I mean, if we're going to print like 100% infill, then I suppose the pattern you make doesn't super matter. But yeah.
One thing I'd recommend is just to not use grid or lines for anything that you need to actually be strong. Those are more for like, I guess, like art figurines. They're not very structurally sound, not as much as the others. That's just a recommendation on what not to use.
That's good. That's good. I see here it says like for grid or lines, it can be printed every layer. So that means like the layer strength, if you like to shear the device or shear the part like horizontally, then it might just like fall apart. But if you have like a 3D structure inside, so it looks like Octet has like a 3D structure inside of it. Let me see if I can take a peek inside here. It's like building, what is this inside?
It's well, an optic, kind of, you know.
Yeah, so it's a nice structure inside. So it looks like that will be much stronger than just having straight up.
Yeah, that's what I found in my own uses.
That's good. Let me actually, I see a chat. What is this? If we accidentally extrude cut something, how do we delete it? Delete the feature. Yeah, good point. Okay, so let's take a look at that actually. Let me just demonstrate real quick. So if I accidentally extrude cut this guy and I don't want this extruded cutted, so what is this? Show me, what is that? That is cutting out these little notches for the screw head. So you just delete the feature. If you delete the feature, I believe for the most part, I hope this doesn't break it. Yeah, then you still, I think do you retain the sketch? You don't retain the sketch. Sometimes you retain the sketch. Since they're both based on Sketch 10 is hidden on the top one. Yeah, so you can just delete the feature. If you accidentally do a feature you don't want to do, delete it, or press the undo button enough times and you'll get away. Let me see. I think also an important setting to do in SolidWorks is, I think there's an autosave, or at least it tells you where your backup saves are. Autosave. Oh no, where's the autosave? Backup and recover features. Yeah, so I set this to 1 minute because I am paranoid. I'm working on a laptop and this thing like breaks every so often. So I recommend setting your autosaves very frequently and show the warnings for saving if you haven't saved for more than a certain time. Recommend those settings. Touch? Oh no, they used, what is this? Touch screen or touchpad? Hopefully they don't. Oh, okay, handwriting. Okay, I thought they were recommending certain features for touchscreen. Okay. But yeah, so here's your auto recovery folder. Keep that in mind. This is where the stuff is. If your Autodesk crashes, if your SolidWorks crashes, it's in there. Same with you can enable backups. I probably should enable that, but I'm not. Okay. Let me actually just pull up the main ROV we're working on so far for robotics. Let's do a stress test on my computer. Frame draft. I think this is not the full one, but it's close enough. Let me close Ultimaker. Cura. Let me close the PowerPoint. And we'll provide the PowerPoint link actually as well. Let me see. Rebuild. These might be a slightly outdated version actually. I need to look for the new one. Let's see. Let me see if I can point out where we have been using some of the things we've been talking about today. Okay. So once again, this is for working underwater. It's designed to go around the bottom of the pool, pick stuff up, move it around, and drop stuff off everywhere. Oh, it's missing the claw. Let me open up the real one actually. It is open recent documents. Shown folder, mate, full assembly versions, RB. Okay, yeah, so let me see. So let's see. We've been talking about like sweeps. We've been talking about sketches, features, relations, patterns, images, text. All right, yeah. Okay, so this is courtesy of Sean. We have little good old dustpan Dave here, as well as side scoop Sadie here on the side. So these guys are picking up dead fish on the bottom of the pool and dropping in a bucket, as well as scraping off like algae from a net, a simulated net in the pool. We have our nice robotics logo here etched into it. I believe that was Sean's handiwork from just doing line work here via lines in the sketch mode. Circular patterns, making the pattern x-axis, y-axis along the surface, cutting it off using fillets, round things off, make it nice and not sharp, safe for people to operate with, not going to cut them, so it's not going to be dangerous for the divers in the pool. We also used, as you see here, as you saw before when Naomi showed it, these are there's a bunch of reference geometry. They're hidden right now because we don't want to populate our screen with too much stuff, but there was reference geometry here to define the holes, the direction of the extrusions and cuts and more. Tomorrow we'll be talking more about how you can put up multiple parts into a large assembly like this, how especially you're going to mate them so that you can move them. So see here, that is the claw. Naturally, it's only be operated when the dustpan is not attached, but we're going to show how you mate stuff so you can have them be dynamic and movable. So you can simulate how stuff's going to move on your robot, on any claws or wheels, stuff like that. Have it let it rotate or move a fixed distance up and down, or maybe hinge. Hinges are pretty fun too. We also have a bunch of thrusters to direct water, so we can move in all directions. Let's go ahead and make this transparent. Right click on it, click on the transparency button. We can look inside the box. We don't have the PCB inside yet, but I also hopefully want to show you guys how we can make PCB files from like Eagle or some other software, I don't know, whatever you use, have it changed into an actual 3D part and just put it into your design. That's actually really cool. It makes your stuff look really nice. And we see here, that's the sweep. That is the tether going up to the surface. Notice how it follows. It says sweep 1, tether stand in. Sweeps up, and there's also a bunch of other stuff inside of it, simulating the other wires within the tether. So that is sweep along a path. I hope that's not a spline. Is that a spline? Don't tell me it's a spline. Well, that's like a spline. Oh man, okay. I didn't make that. I'm glad I didn't make that. That looks painful. Okay, and let's see. We'll also show you how we have been using like, there is a nice plugin called HSMWorks. It's made by Autodesk, but it works for SolidWorks. That helps us process these large panels. These are not 3D printed. These are HDPE. I was talking before. We cut them out of large sheets, drill holes into them using the X card, a large CNC machine, 2.5 axis mill, and then we put them together and they fit nicely. It lets us to make precise cuts so that we can slot them together. It's like what? It's like a craft kit or something pretty much at this point. Just put them together, lock the screws in, and then it's good to go. Have notches where they should be, etc. And cheese hole everything, so you can put a bunch of modular attachments to it. It's really nice. So we'll show you guys that tomorrow, hopefully. We have a lot more stuff to go over tomorrow than today. So I'm not sure if we'll be able to fit everything, but we'll try to get as much as we can. Okay. Yeah, we use a lot of stuff we talked about today, actually. We use pretty much everything. I don't think we use global variables on this one, actually. I don't think we use any global variables here. Yep, no global variables, but Yeah, pretty much everything we touched on is used here. I've used section view a lot to take a look at the bottom half of the robot. Sometimes I only want to look at this and not get all the stuff on top in the way. I just chop it off like that, and voila, I can see the bottom half of the robot. As you guys think of any questions you have, let me go ahead and pull up the topics for tomorrow. Give you a little preview of what we're going to go over tomorrow. The chat here. Thank you very much. Oh, no worries. I'm glad to share this with you guys. Hopefully you guys can avoid some of the pitfalls we've made, bad practices and broken assemblies. Hopefully you can avoid those with these tips. And especially tomorrow, we'll show you guys good standards to keep when making assemblies. So you guys have nice, accurate, and not broken 3D parts. Okay. So tomorrow, in particular, we're going to take a look at multiple part assemblies. Take a look at routing cables. That might be cut actually. I'm not sure if we have enough time for that. But evaluation using the measure tools, thickness checks, interference checks, see if anything's clipping. CAM, that is the milling stuff, cutting stuff out from large sheets of stock material. HSM Works plugin for SolidWorks, tips, CNC stuff, metals, plastics, laser cutters, maybe, I don't know. Short break, and then we'll talk about simulation in SolidWorks and how to make stuff nice and make presentable stuff, renders, appearances, adding materials to it, gloss, shine, mirror, etc. Camera views. So we'll talk a bit more about all these stuff tomorrow, 2 to 4 p.m.